Well, hello everybody. So what's going on here? In this series of videos, I'm gonna be explaining to you smart contracts. You can think about it as a smart contracts course. So first thing first, what are actually smart contracts? You can think about like regular contracts, those things we write on paper that contain several terms, and if parties agrees on that terms, they can sign it, and now they are liable to the terms written in that contract. But this one is different because you can see here it's smart, and that actually because it is written in code. It's programmable, which makes it like we are able to add a lot of cool features into it. The important thing about smart contract is that it runs on an underlying technology called blockchain. So when we mention blockchain, we usually associate it with Bitcoin, but smart contracts doesn't have to be actually associated with a certain cryptocurrency. It's like a different concept, but they're both relying on the same technology, which is blockchain. But in this course, smart contracts are gonna be tied to a different blockchain network, which is called Ethereum, and Ethereum is providing us with another cryptocurrency called Ether. So this is what we're going to be talking about in this course. So the question is now, still we don't know like what is actually a smart contract. What can we do if we're using smart contract? So let us think about a scenario here. So this is just an example when we have here two actors, Bob and Greg, and Bob wants to rent that house that is owned by Greg. And the cool thing here is that Greg is a cool techie kind of guy. He's using the dark magic of IoT in order to control his house. So he is gonna be giving Bob, as the guy who's renting that house, authorization in order to use the facilities in that house through the IoT. One of that is that the door, for example, Bob needs to be authorized in order to open that door. So in order for that to happen, like Greg is building like this sophisticated web application with this sophisticated UI, and you just ask if you want to rent my properties, and he asks like for how long. Then Bob, for instance, gonna say like I want to rent that property for 5 months, and Bob is gonna be authorized to use that house for that 5 months. So he's gonna be able to open that door for 5 months, and when those 5 months end, he's not gonna be able to use that house. So everything is cool. But what if Greg is a sneaky guy who just can't be trusted, and for some reason he is irritated by the presence of Bob, and he backed up from his deal, and he wants to kick Bob out after 2 months? He can change that web application, change the records, and just she just can kick him out. So this is a problem here. Like Bob can't actually trust Greg. After all, he's the one who built that web application. So this can be an arbitrator for that situation. So in that case, we have a third party, some kind of a trusted third party, acting as a mediator between Greg and Bob. Usually in our world now, when we think about trusted third party, we think about banks that does transactions for us between different individuals. So in that situation, the bank is building the web application, and he's gonna be acting as a mediator between Bob and Greg. Bob is gonna enter to that web application, and he's gonna tell the bank like I want to rent it for 5 months also. But this time the bank is now the trusted party between both of them, and this is actually the world we live in today. But still there is a little problem now. So imagine now there is an insider working in that bank. For instance, he's named Oscar. And for some reason, Oscar just doesn't like Bob. Maybe he's dating his daughter, and he just Oscar wants to kick him from that house in order to make him look like a loser, because he doesn't like the fact that he's dating his daughter, and he wants her to leave her. Whatever, I don't care about the story, but he just can't be trusted, and he's having access on the records in that bank, and he can change it so that he's no longer able to use the facilities in the house, and effectively he's going to be kicked out of the house because he can't even open the door. So that problem actually arises from the fact that despite this is trusted third party, it's still acting as a single point, in which if that single point is compromised, then the records can be compromised too. So another scenario now, which is gonna be discussing in the course. Imagine there is a smart contract, like a code, a contract written in code, and Bob can like call functions in that contract, like agreeing in that contract, and Greg agreeing to that contract. And once both agree to that contract, nobody ever can change it. So in that situation, we're gonna be having the web application is gonna be called DApp, which stands for distributed app. This application is interacting with the contract. So once Bob says, I wanna stay for 5 months here, this is gonna trigger functions in the contract in which enables Bob to use that facility for 5 months after Bob agrees, after Greg agrees. So everything is gonna be fine because no one can back up from that. So how actually this thing works? What makes it trusted, even more trusted than the third party? Because technically this smart contract is like running everywhere. There is no single point in which you can compromise that contract. Like imagine all these nodes actually are running that contract, and you can't compromise them all. So it makes it really powerful, and it takes power from the big institutions and actually distributed it kind of to the people, because all these nodes, you can be one of them. So this is the power actually of blockchain here. So now if Oscar wants to compromise that deal, he can't, because he just need to hack like literally everything. So what do we need in order to be able to write smart contracts? So these are basically the topics here. You're gonna need to understand the blockchain itself, blockchain technology itself, and we need also to understand Solidity. This is a new programming language. Maybe you know, maybe you don't, but you have to be able to know that language in order to write smart contracts on Ethereum. After that, you need, and it is essential, to test your smart contract written in Solidity. And this is different from other web applications because testing here is essential, because once you made a contract, you can't back off from it. After that, you write the smart contract. You need to write the application that triggers the smart contracts. And these are called dApps, which stand for distributed apps, because this application is not running on a single point. After that, we can have some kind of a different thing here. Actually, if you learn the first 4 topics, it's enough to be able to write smart contracts, but I would encourage to go further and write the smart contracts, make them as tokens, which is some kind of, you think about it here, like the standardized form for smart contracts. After that, there are like other topics here, maybe like oracles, like how to upgrade the smart contracts. All the previous topics are enough to make you like a blockchain developer. But of course, when you come to real world applications, you need to learn about other topics. In this course though, I will not be touching upon the blockchain. I don't want to bore you with details. I want to get your hands dirty quickly with programming. It is really essential to know about blockchain, but I will tell you, like, you can somehow be able to work even if you don't understand blockchain to some extent, because actually this topic needs its own course. There are so many details in it. There are mathematics inside it. It's really like the foundation for that, but you can still be able to program. So I hope I see you in the next videos.